Hello everyone, now we are going to solve the questions based on the turning moment diagram. In the question what is given, a turning moment diagram for a multi-cylinder engine is shown in figure. The area in centimeter square of the turning moment diagram above and below mean torque line. This line in the diagram you can see, this is the mean torque line. Okay, and we all know that the area above the T mean line is considered as positive and the area below the mean torque line is considered as negative area. So I can write here this is negative and this is positive and this is negative, this is positive, this is negative and this is positive and again this is negative. And we have read one other concept that the summation of, we have read in the lecture that the summation of all the positive area above T mean line is equal to summation of all the negative area below T mean line. Yes or no? We have read that. Okay. So let us assume that this is point, this is point A and this is E A. This is the energy at point A. This is EA and here it is EB and here it is EC. Similarly ED, that is EE, that is EF, that is EG and that is EH. So I'm just assuming that, let us assume that EA is equal to E. Okay, let us assume that EA is equal to E. Okay, now what would be the EB? That means energy at point B, it would be considered as E. What would be E minus A1? And what is A1? Here you can see 0.5. E minus 0.5. Okay. First we will write this values as it is, then in finally we will convert it into that means according to 1 centimeter is equal to 7,000 Newton meter and 1 centimeter is equal to 30-degree crank rotation. So we will convert it into later, but first we will write it as it is. Okay. So next EC would be EB, that EC is equal to EB plus A2. Are you getting my point? So I am writing that EB plus A2. So what is EB? That is E minus 0.5. You can write in a simple way. Okay. You can write also it as EB is equal to E minus A1. And minus A1 means E minus 0.5. Okay. So this is EB plus A2 and what is A2? A2 is 1.2. So that is E minus 0.5 plus 1.2. So when you solve this, you will get E minus 0.7. Okay. So that is what you will get when you subtract 0.5 from 1.2. Okay, 0.7. Now, similarly, you can find out ED. That would be EC. You have to do the same procedure. EC minus A3 because A3 is in, that means A3 is below T mean line. So that is EC is what? EC is E minus 0.7. So E minus 0.7 and what is A3? A3 is 0.95. So here I am going to write that 0.95 and you will get 1.65. That means E minus 1.65. That is what you will get here. Okay. Similarly, we can find out EE. That is nothing but ED. In the graph, you can see this this is ED, and then we go to the positive area. That is plus A4. So ED is what? E minus 1.65. 1.65 plus A4. A4 is A4 is in the table, you can see that is 1.45. So I can write here plus 1.45. So when you calculate this, you will get E minus 0.2. That would be E minus 0.2. Okay. Similarly, we can find out EF. That is nothing but EE minus A5. So that is the EE minus A5, and that is nothing but E minus 0.2. And what is the value of A5? You can see in the table. That is 0.85. 0.85, and when you calculate this, you will get E minus 1.05. E minus 1.05. Now you can calculate here remaining the one, that is EH. EH is equal to EG minus A7. Okay, and what is A7? You can see here in the diagram. First we need to calculate here EG. We have not calculated EG, sorry. So first we need to calculate EG. You can see here that EG is equal to EF plus A6. Okay, so that is EF plus A6. Okay, and what is the value of EF? Actually, we need to check it. Is there any mistake in the calculations? Okay, so here there is a mistake. You can see here that is minus 0.5 plus 1.2. You will get plus 0.7. So this is a mistake in the calculations here. So this is plus 0.7, and when you calculate this, you will get 0.25 here. So I have to change all the data again. So this is E minus E plus 0.7 minus 0.95. You will get E minus 0.25. Okay, so I'm just doing fast because we have calculated already. 25 plus A4, that is 1.45, and when you do this, you will get E plus 1.2. E plus 1.2, and here that is 1 E plus 1.2 minus A5, and A5 is 0.85. So here you can get the value of EF, that is E plus 0.35. Now we can calculate the EG value, and that is EF, that means E plus 0.35 plus A6. A6 is 0.71, so plus 0.71 here. So you will get here 1.06. That means E plus 1.06 you will get here. Similarly, you can find out the value of EH, that would be EG minus A7, and you will get E plus 1.06 minus A7 means 1.06. So you will get value again E, that is equal to EA. So you can reach to the initial point, that means it would be equal to the initial value. You can cross check it. Here in the bracket that is written at that as is equal to A, that means whatever be the value of energy here, that would be equal to the energy at E. So that is what we have said, that the summation of all the area above the T mean line is equal to summation of areas below T mean line. Okay, so because here that is E is equal to A, and finally you will get again E. That is the method to cross check whether you have mistake in the calculation or not. If you get some value here, that means you make a mistake in the calculations, you have to revise the procedure. So finally here we have get the initial value, that means we are doing same, that we are doing right here. Now first we need to calculate the maximum change in energy. That means maximum fluctuations energy, that is equal to delta E max is equal to E max minus E min. Okay, so what is the value of E maximum? You have to find out the maximum energy value here. You can see here that is E minus 0.5, E plus 0.7, and you can see here that is 1.2 and 0.35, and that is 1.06. So you can see here this is basically a maximum value. Yes or no? This is the E maximum. All the above data we have seen that E plus 1.6 is the maximum value, and we have to find out the E minimum. So that is minus 0.5, minus 0.25. So here you can get the value of E minimum, that would be E minus 0.5. Okay, so that is the E minimum. Now you just have to put the value here. E maximum is nothing but, I'm writing here delta E. Delta E is equal to E maximum is 1 E plus 1.06 minus E minimum. E minimum is E minus 0.5. You just have to put the values directly, and thus you can see this would this is actually E minus 0.5 is in bracket. Okay, so use the bracket. So that is E plus 1.06 minus E plus 0.5. So you can see here this would be cancelled out, and finally you will get the value of delta E maximum, and you can calculate here that is 1.06 plus zero point 0.5, and you will get the value 1.56. And what is the meaning of 1.56? Basically this is the summation of area, so this is the centimeter square. Okay, now we all know that the energy having the value Newton into meter. Okay, are you getting my point? So Newton into meter, and there is the angle theta. We know that this is the centimeter and centimeter. Okay, if I can write centimeter square is equal to centimeter multiply centimeter. So I can write here that is 1.56 multiply centimeter. 1 centimeter, you can see 1 centimeter 7,000 Newton into meter. So that is 7,000. Now again there will be a centimeter which is multiplication, so there will be 30-degree rotations, but we have to write here this is not this is actually multiplication, so this is 30 degree. You have to use radian. In radian, units must be radian, so we can convert theta into radian. So this would be the delta E, that means the fluctuations of the energy you can get here. So when you calculate this, you will get the value of maximum fluctuations of the energy, and that would comes out to be, and you just have to use the calculator and do the correct calculations, otherwise you will make a wrong answer. Okay, and finally that is the value you will get, that is 5717.69. This would be in Newton into meter. Okay, this is basically delta E, or you can say the maximum fluctuations of the energy. Maximum fluctuation of energy. Are you getting my point? So, but in the question it is not asking maximum fluctuation of energy. In the question, the engine speed is given. That means omega is given. Omega is 94 radian per second. 94 radian per second, and it is desired that the fluctuations from the minimum to the maximum speed. This is what about the speed. Okay, maximum fluctuations of the speed should not be more than plus minus 3% of average speed. So we know this is the value of CS. Plus minus 3% means it is 6%. That means CS value is having 0.06 value. So we are having the omega value and we are having the CS value. We can get the value of moment of inertia of the flywheel, that is I. Okay, so we all know that maximum fluctuation of energy delta E is equal to I omega square CS. We have seen this formula, I omega square CS, and we are having the value of delta E, that is 5717.69 that is 5717.9, and that is equal to I, that is the moment of inertia we have to find out, and omega value is given 94. So 94 square multiply CS, and CS means 0.06. So when you solve these equations, you will get the value of moment of inertia. So I'm just solving this using calculator, and you just have also try this, what the answer you are getting. So finally the moment of inertia that you will get here, that is 10.78 kilogram into meter square. So that is the answer we have got from this equations, and that is the moment of inertia, that is the 10.78. 10.78 is the final answer. I hope you are getting the solution of this question. Okay, you just have to, this diagram, this is the turning moment diagram, you have to solve this for finding out the fluctuations of the energy. This is the maximum fluctuation of energy. So you can find out the E maximum and find out the E minimum, subtract them, and you will get the value of E maximum. And the formula we all know that delta E is equal to I omega square CS. And whatever be the asking in the questions, you can find out from these equations. Okay, this is very important equations in the flywheel. So I hope you will understand the solution of that question. Thank you.